Dear children, welcome to the physics class. In the last class, we discussed about the type of charges and their interaction. So we learned in this lesson that the naturally we can charge an object by rubbing. So rubbing is a natural method of charging an object. And you know that all the objects are electrically neutral, or the same number of positive charges and negative charges are present in the objects. And when we rub the object against any other appropriate object, sometimes the number of positive charges may increase, or the number of negative charges in the material or object will increase. So if due to the rubbing process the number of positive charges increases, means we say that that object is positively charged object after rubbing. And if an object or a body is getting more number of negative charges, or they acquired more number of negative charges, means we say that that object is negatively charged object after rubbing. So there are two types of charges. These are the two types. An object can be a positively charged object after rubbing, or it can be a negatively charged object. That depends on the charges, depends on the nature of the rubbing. Okay, so this is the natural method of charging an object. Rubbing is the natural way of making or changing an object into a charged one. So there are two types of charges, positive charges and negative charges, and due to rubbing sometimes some material will acquire more positive charge, or they become positively charged object, and sometimes some material may obtain more number of negative charges. We call them as negatively charged objects. Okay, so and these are the two types of charges acquired by the rubbing process, positively charged and negatively charged. Okay, and what will happen when we bring a positively charged object nearby a positively charged object? They repels each other. But when we bring a negatively charged object nearby a positively charged object, there will be a force of attraction. So there are two types of forces between the charges. Unlike charges always repels each other, and unlike charges always attracts each other, and the like charges or similar charges always repels each other. Like charges always repels each other, and unlike charges always attracts each other. So there will be a force of attraction between two oppositely charged materials, and there will be a force of repulsion between the two bodies which are having same charges. Positive attraction, repulsion, negative attraction, negative repulsion. Okay, that is all about the type of charges and their interaction. Okay, and next we studied about the electroscope. In the last class we discussed about an electroscope, and electroscope is a device which can we can use it, or we can make by yourself, and we can use it for detecting the charge. By looking, we cannot say that an object is charged or not. That is not possible. We cannot see the charges, and they cannot move also. We can't see the charges in the material after rubbing, and they are not in motion, they are stationary. And even though it is stationary, we are not able to see the charges present in the material. But we can detect the presence of the charge with the help of a small device called an electroscope. So electroscope is a small device which we can use that device to detect or to find whether an object is charged or not. Okay, so let us study about the construction and the working of an electroscope, and what is the design of the electroscope. So we can make it very fastly. So this is it consists of a vessel like this. Electroscope consists of a vessel, and a metal rod is inserted into the bottle with the help of a cardboard. A cardboard is placed on the mouth of the vessel or bottle, and through a hole is pierced through the cardboard placed on the top of this mouth, and a small metal rod is inserted into the bottle. This is the metal rod having a hook at the bottom end of the metal rod, and two silver foil or two strips of the aluminum foil, two strips of aluminum foil. We can use silver foil or gold foil, whatever it may be, but in the textbook it is given aluminum foil, so I am using the same strips of aluminum inside the bottle. And the two strips or two sheets or two pieces of aluminum foil is placed at the hook, or it is hung from the hook of the electroscope. Okay, and this is all about the construction of the electroscope. Electroscope consists of an empty bottle, and it is the mouth is closed with a cardboard, and through the cardboard a metal rod is inserted into the bottle, and the other end of the metal rod is from the other end of the metal rod, two small pieces of aluminum foil are placed. Okay, and what we want to, and this is now the device is ready to find whether a material or object is charged or not. For that, what we want to do is, suppose we are taking scale as the charged object. So what we want to do is take a scale, rub it against your hair for many times, so that the plastic scale become a charged one, and take the scale and place it inside, place it in touch with the metal rod of the electroscope. Okay, and you can place the scale in touch with the metal rod of the electroscope. Then what will happen? Suppose this is the scale placed near, or that is in touch with the metal rod. What happens? Suppose this is positively charged material having more number of positive charges. What will happen when we touch the metal rod of the electroscope with the charged scale? We don't know whether it is charged or not, but we are touching the object with the metal rod of the electroscope. So what happens is, the charges start moving. This is transferring of charge occurs. The charges from the scale started moving down through the metal rod of the electroscope, and it reaches the different two pieces of aluminum foil also. So the entire thing inside the bottle, this metal rod as well as the aluminum foil, are now acquired some charges that is shifted from the scale. So this charge just started flowing from the charged object. The charges are flowing through the metal rod, and it reaches on the two strips present inside the bottle. Then due to the accumulation of the same charges on these two strips, what happens is the two strips started or they move apart, or they disperse each other because of the like charges. Okay, and by keeping an object in touch with the metal rod, and we just look at the movement of the strip, if they are dispersing each other or if they are moving away from each other, we can say that the same charges are accumulated on these two, or the object that is in touch with the metal rod of the electroscope is a charged one. If there is no charge in it, what will happen? No charges will flow from the scale to the other metal rod of this electroscope, and nothing will happen to the aluminum foil. That will remain without any movement. Okay, so if they are dispersing each other, or if they are moving apart from each other, we can understand the material that is in touch with the metal rod of the electroscope, that is a charged one. If there is no movement for the strips of this, we say that the object is not charged. Okay, this is the way in which we can find an object is charged or not due to the transferring of charges. The charges can easily, when we touch the this type of charged object with a conductor, this is the conductor of charges. Metal rod is a conductor. All the metals are good conductors. So because of that, the charges can shifted from the scale to the conductor, and it reaches the aluminum foil, and it makes the aluminum foil to disperse each other or to move away from each other. So if there is a movement between movement for these two strips, if they are moving away from one another, we say this is charged one. If there is no movement, no charge in the object that is placed near to the in touch with the metal rod. This is how an electroscope works. Okay, and next we think about this transferring of charge. This is the transferring of charge from scale to the metal rod of the electroscope, or transferring from here to the aluminum foil. And next we are thinking about how do the is it possible for the charges to move from the cloud to down, or if it is possible to move the charges from one material to another material, from cloud to earth, or from within the clouds itself, or from an electric device to the earth. That is also called the transferring of charge. And here you see these are the clouds present in the high up of the atmosphere. So we can see the clouds from down. So these two are the suppose these two are clouds A and B. Okay, and here is the ground. Clear? And all the objects can have some charges. Okay, all the materials, even the clouds are also having some charges. Some clouds are positively charged clouds, and some clouds are negatively charged clouds. Okay, and the charges can be accumulated in the clouds due to the collision of the clouds. Okay, and when the clouds are having more number of charges, they started moving from the cloud to the earth. Start from the clouds to the earth. Here air is present, and through the air the charges can be moved, coming out from the cloud, and they can come towards the ground. This is the ground. Clear? And this discharging charges can be flow from the clouds to the earth. This is what is called a discharging of charges. Okay, and this discharging is called lightning. Lightning is the discharging of charges from clouds to the earth, or they are moving. Charges are moving from up to down, or from the cloud to the ground, and this is called this is the reason. This is how the lightning occurs. Okay, lightning is always followed by a great sound. We call, what is the name of that sound? Thunderstorm. So lightning is always followed by thunderstorm. Okay, so we can hear the sound later, and we see the streak of light first, because the light can travel fastly than the sound. Sound waves are having sound that is lesser than the speed of the light waves through the air. Okay, so we see the light first and we hear the sound after some time. The thunderstorm can be heard afterwards. First we see the streaking of light, or the discharging of light can be seen. Okay, and this is a this is how lightning occurs in the atmosphere. Okay, and that is nothing but the discharging. And here in our house also we can see the discharging, or we can see some spark of charges when we plug in, or when we when we switch on the lights, we can see the spark of light at times, or when we insert the pin into the socket, we see the sparking of light, and that is in a very small scale, or very less number of charges are discharging, or the charges are coming out, and it won't make any disturbance. But if it is in a large scale, that occurs the lightning, or a continuous charges are flowing, means it can make electric current, and that can make more disturbance to the people